Well, I had planned to use a fabulous clip from The Big Bang Theory and have Sheldon Cooper explain the rules to rock, paper, scissors, lizard, Spock. But unfortunately, the copyright police told me that was a very bad idea. So since my wife thinks that I'm already a lot like Sheldon, I'm going to take my crack at explaining the rules to rock, paper, scissors, lizard, Spock, a la Sheldon Cooper. Let's do this. It's very simple. Scissors cuts paper. Paper covers rock. Rock crushes lizard. Lizard poisons Spock. Spock smashes scissors. Scissors decapitates lizard. Lizard eats paper. Paper disproves Spock. Spock vaporizes rock. And as it always has been, rock crushes scissors. Yeah. Well, I hope you enjoyed that. Our mini project for the end of week 1, and the first one that you'll turn in for a grade, is rock, paper, scissors, lizard, Spock. Now, when we were brainstorming on kind of what mini projects we should use for this class, our first inclination was to do something on income taxes. So I kind of bounced this idea off of my focus group at home consisting of my 3 kids, and their reaction was, income taxes, yuck! Who wants to do income taxes? So we watch a lot of Big Bang Theory at home, and so they came up with the idea, hey, yeah, let's do something on rock, paper, scissors, lizard, Spock. So that's where the idea came from. In this video, I'm going to do 2 things. I'm going to start off by walking you through the rules for rock, paper, scissors, and then later rock, paper, scissors, lizard, Spock. And I'll show you kind of a clever idea for how to determine who wins the game of rock, paper, scissors, lizard, Spock. And in the second part of the video, I'll walk you through the mini project. And then in particular, I'll show you how you can get help if you're having trouble actually completing the mini project. We've got kind of some nice support structures in place in the class, and I'll try to show you how to use those. And if you get stuck, you should come back and look at this video because it'll give you some nice hints about how to proceed. Okay, let's go on and get started. All right, let's go through the rules of rock, paper, scissors, lizard, Spock a little slower. So this is just a variant of rock, paper, scissors. We have rock, paper, and scissors. So rock smashes scissors, scissors cuts paper, paper covers rock. The problem with playing rock, paper, scissors is that you tie a lot. And if you play friends where they kind of know your patterns, you may tie more than half the time. So one way to avoid having lots of ties is to add more items. So this variant, you add in lizard, and you add in Spock. And this little poem over here is actually what Sheldon recites on The Big Bang Theory to describe it. My kids love it when I do this. But I don't expect you to actually program this rules in your first project. I'm going to tell you a simpler way using, surprise, surprise, modular arithmetic. So over here I have the rock, paper, scissors, lizard, Spock wheel. And in fact, it's really the rock, Spock, paper, lizard, scissors wheel. And the way to remember this is you put Spock next to rock and lizard next to scissors. Now, why is this wheel useful? It's because I can figure out who I win and lose to based on where I sit on the wheel. So let's consider Spock. Spock always beats his counterclockwise opponents. Spock vaporizes rock, Spock smashes scissors. But he always loses to his clockwise opponents. Paper disproves Spock. Lizard poisons Spock. In fact, this holds for every item on the wheel. So if we want to go through and figure out who wins at rock, paper, scissors, we can take the numbers for each of the items and when we look at their difference. So we could take paper minus Spock. Okay. Paper appears to the clockwise, so 2 minus 1 is positive, it's 1. Therefore, paper beats Spock. Okay. Lizard, 3 minus 1 is 2. It's actually clockwise. What about, let's see, we have scissors minus Spock. So we have 4 minus 1, that's 3. Well, let's see, 3 has gone far enough around where we're actually kind of counterclockwise. In fact, we have, let's rock. Rock is 4. So we have 0 minus 1. That's negative 1. Gosh, what do we do there? Oh, we could use modular particular remainders. We could go through and take minus 1 remainder 5. Remember what I talked about. Whenever you have a negative number, you're taking a remainder. You can just think about adding in the number you're taking the remainder with as many times as it takes to get it in the range between 0 and 5. So here if we take negative 1, we add 5 to it, we get 4. So the rule is really that if you take the first item minus the second, if the difference is 1 or 2, the first item wins. If the difference is 3 or 4, the second item wins. So we'll go and see that in a program template in a second. But this is a simpler way to actually program this up. All you're going to need to do is build an else, else if, else if, else clause, and use a little modular arithmetic. So let's move on to the program template, and we'll be more tangible. All right, let's walk through building rock, paper, scissors, lizard, Spock. You should understand the rules from now, so let's go out to the home page and we'll click on the mini projects link, scroll down, and we'll go to rock, paper, scissors, lizard, Spock. So just like for mini project 0, we have a description of the mini project. It has some kind of an overview here, kind of the same thing we talked about in the previous segment. And then it has a very detailed step-by-step walkthrough of implementing rock, paper, scissors, lizard, Spock. Please read this. This gives you important hints on how to implement the project. For example, it mentions when you're generating random numbers, you use random.randrange. So read that. It'll give you lots of nice hints on there. Notice it also includes what the output of the program should look like. Okay, so if you're curious kind of what it should produce something in this format. It includes a grading rubric that discusses kind of how to handle deviations, and then gives you items for how to evaluate if your implementation is correct or not. So it's important that you familiarize yourself with this. One important point here, the first rubric item says you need to use Code Sculptor. So don't try to cut and paste your code into the submission box. I know it's tempting because you want to use a tool like idle. Well, you could kind of get by with it for this project, but in the future you're going to need to be using Code Sculptor because a lot of the interactivity is going to take place inside the web browser. It's not going to be able to be implemented inside idle. So just get used to it now. Use Code Sculptor. It's going to make peer assessment much more reliable and much more easy. When you're ready to start writing code, you can scroll up here. We have a template. Every mini project has a template. We can click on this. And this pops up basically a Code Sculptor URL, which kind of contains the starting point for your project. Really, if you look at the project, there's really 3 things you need to do. You need to implement a function number to name, a function name to number, and a function RPSLS. So you kind of have to fill in these comments with Python code. At the bottom, there are 5 calls to RPSLS that will essentially test if your implementation is correct or not. So when you run your code, you should expect to see some text appear over here. And we've actually echoed that text right here for you. Okay. I'll also show it to you in the video so you can actually see it in action. This is my implementation of rock, paper, scissors, lizard, Spock. You might ask, well, where are my definitions of these functions? I've used a function, basically a kind of a feature of Code Sculptor called code folding. If you right-click in this little column here, you can actually either fold up and hide code or expose code. I've actually hid the definitions of number to name, name to number, and RPSLS. If I run this, what you can see here is the textual output. So notice a couple of things about this, that using random numbers, I made kind of a different response for the computer on each particular individual game here. So I didn't always choose the same value for the computer. And then if I run this again, I see different choices for the computer. Notice the player's choices are always the same for every single run, and that's because we have these 5 values here. So this is kind of a way to get you started on doing rock, paper, scissors, lizard, Spock. Now what I'll do next is I'll walk you through how to get help if you get stuck in implementing the mini project. Okay, you're working on your mini project and you get stuck. It's going to happen. So what do you do to get through and finish off the mini project? Well, the first thing you can do is, if you're confused about some particular Python concept, go back and take a look at the appropriate class video. For example, if you don't understand how conditionals work, take a look at Scott's video on conditionals. We tried to include in the videos all the concepts that you need to finish that particular week's mini project. Okay, that didn't get you unstuck. All right, go back and look at the mini project description again. In particular, take a look at the development process. There are lots of details here about how to actually implement the project. If you're not following the development process, it's easy to get lost. So if you're having trouble, go back and take a deep look at it. Okay, that still didn't help you. You're still confused, don't understand what to do. You have a tremendous resource available here, and this is something that only happens in really large classes. We have the discussion forums. So we spent a lot of time in designing the discussion forums. So in particular, we have forums for mini projects, and we have a forum for rock, paper, scissors, lizard, Spock. And I've already got a post in here. We'll talk about it in just a second. But when your peers start working on this project, there are going to be literally tens of thousands of people trying to do this project. There'll be a blizzard of posts, lots of posts here on all kinds of topics related to probably something that you're having trouble with. So spend some time in the forums. There's a great search feature here. We got a search box right here. Kind of use the search box and try to locate an existing thread that answers your question. If it's kind of close but not exact, you might actually add another post to that. Or if you know something, how to answer a question, add something there. You're going to see that most of the threads get lots of posts in them from people either asking more questions or trying to help. One nice thing about previous sessions is we have people that are actually fairly experienced with Python here that really want to help everybody else learn how to program in Python. If it turns out that nobody's asked your question, start a new thread. Okay? Be polite. What will happen is typically it won't take too long, maybe 5-10 minutes most, and you'll get a few people that are trying to ask your question. Now, one thing is the class has an honor code, so you can't post a link to your working or almost working mini projects. So you may need to use questions along the lines of, I don't understand how conditionals work. Or maybe show a little small portion of your code and say, this particular piece of code doesn't work. If you're stuck and you really don't know what to do, I'm going to show you one more thing that you can do. And this is something that's unique to this class, and we're going to do our best to help you out with. So give me a second, and I'll show you kind of your method of last resort. All right, you've consulted the forums and you're still stuck. We've still got more help for you. The next thing I suggest you do is inside Code Sculptor, there's a button up here that says Tips. This links to a particular thread inside the current week's mini project forum. So here we're in the forum for Rock, Paper, Scissors, Lizard, Spock, and I've created a thread called Code Clinic Tips for RPS LS. So in this thread, I've essentially posted some information about students' errors and things to help with solving this particular week's mini project. For this session, what we're going to do is we're going to always start off with some essentially testing functions that help you make sure that the helper functions you're building for your mini project are correct. So remember, you have to implement name to number and number to name. We've put out here 2 Code Sculptor URLs that you can use to test to see if your implementations of those functions are correct. So for example, if I click on this, it pops up a Code Sculptor URL, which has a place for you to paste in your definition of name to number. And then it has some test calls to name to number with appropriate input data. And it tells you what should come out of that, what the output format should look like. So if your implementation of name to number is correct and you paste it in here, you should see something like this coming out. This basically gives you a way to check and see if your helper function is written correctly. If it passes this test, there's a good chance that implementation is correct. There's also one here for number to name. The thread also includes observations from previous iterations of the class. Here's some examples of kind of common errors that I've observed in working with students. Things like always capitalize Spock, Python is sensitive to case. There's one thing I mentioned here. What's this thing called the Code Clinic? So how did I get all these observations? The other instructors, and the community TAs have a special email address that we've set up where you can, as a matter of last resort, send requests for help. For this session, it's interactivepython@online.rice.edu. Send an email to this. We have a professional help desk that's actually helping us. You should get an automatic response. If the Code Clinic is overloaded, you'll get a response saying it's going to take a long time. You may not get a response. Your email will actually be sent to one of the instructors or one of the community TAs, and they'll have a chance to help you. Now, this class is going to have many tens of thousands of students. If you're all trying to do the project at once and there's maybe a dozen of us trying to answer email, this is only going to work if you use this under the following circumstances. You've tried all the other ways I've discussed of trying to seek help. You only send us an email with a Code Sculptor URL that's relevant to the current week's mini project. This is not a way to get questions answered about concepts about the class. Post that in the forum. We're going to ignore all of the requests. But if you're stuck and you think, man, I know I'm just like one little change away from getting the mini project done, and you're getting frustrated, send it here. We're going to do our best to help. What will happen is, at the end of the day, we'll try to send you back maybe a modified code sculptor URL that will point out where your error was or give you a hint in terms of trying to do it. It may turn out there are too many requests, and so this is something that we're doing our best at here. My wife, I actually spent so much time in the code clinic last time, my wife actually got me a custom t-shirt for this. We're going to do our best to help every single one of you. And so please be patient with us, especially on this first couple of mini projects if we get overwhelmed in there. We've got better technology this time, we're going to do our best. But again, only use it for code that's sick. If your code is feeling ill and not doing very well, send us a URL, we'll take a shot at helping fix it. Okay, good luck on the mini project. You can do it.